Hi student, today I'm going to continue part 4, I think, of the liquid extraction process. Okay, so today I'm going to cover to you how to draw a triangular diagram, okay, using the data given for the equilibrium. Okay, so basically you can find this data from appendix 3 at the back of your Gia Copies textbook. Okay, appendix A 3.24, A 3.24. Okay, so basically this side will be the water layer or aqueous layer, and this side will be the organic layer. So how do we draw this triangular diagram? So basically, as I have illustrated to you, okay, you can get this scale by drawing a rectangular of equilateral like a triangle, okay, whereby the area or the angle of the triangle should be at 60 degrees, okay. Otherwise, you can just simply Google one of the triangular diagram, empty triangular diagram in the internet. Then you can just print it for the purpose of drawing this exercise. Okay, so let's look at this data. Okay, basically you should have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 points, and this point should be connected to this one, as I told you before. Okay, let's see. For instance, point number 1. I'm gonna look at this point first, which is equal, when you divide by 100, this is equals to 0.464. Sorry, you do not need to divide because it's already in decimal point. But if you look at the appendix A, 0.3.24, it is in percentage. If it's given in percentage, then you need to divide by 100. But this one is already in fraction, so you can just straight away use the data. Okay, so 0.464 representing acetic acid in aqueous layer. Okay, so if we follow the scale for acetic acid, okay, if you look at this point, it should be 0.4640 of acetic acid in aqueous layer. So acetic acid is 1 here, meaning pure component. That means when it is pure component, then the max fraction should be equals to 1. Okay, so we have to read the scale in this perpendicular line, okay, perpendicular line to the base of this base. Okay, so this will be 0.1, 0.2, 0.3, and 0.4. So 0.46 is around 1, 2, 4, 6, around here. Okay, around here. Okay, and then you will have 0.371 of water. So water, you have to use this scale. Okay, and you have to read the perpendicular line from this base. Okay, so basically this is 0.1, 0.2, 0.3. So 0.37 is around 2, 4, 6, 6, 7 is around here, and 0.165 of ether, and we have to measure ether from this is equal to 1 ether, then 0 ether is here. Okay, so we starts to calculate 0.165 from this base until to that 1. Okay, so meaning 0.1 ether, 0.165 meaning 0.2, 0.14, 0.16, it is around here. So as you can see, okay, this first point correspond to this value, if you notice. Okay, I missed 1 here, 0.165. Okay, so it should be 0.464, 0.371, 0.165, as we have calculated from all the 3 scales. Okay, next we are going to plot this point. Okay, 0.362 of acetic acid, meaning 0.1, 0.2, 0.3, okay. 6 is around here. And then we have 0.151 water. 0.1 water, this is 1 water, then this is, should be start 0. 1, 1, 5 should be around here. Okay, and then we have 0.487 layer. So ether, we have to measure starting here because this is 0 ether. This is 1 ether. 0.4 meaning 1, 2, 3, 4. 4, 8 means 2, 4, 6, 8 ether. So basically, the next point is around here when you join all these 3 lines. So basically, when you get to this point, it is the intersection of 3 points of 1, 2, 3. Intersection of 3 lines. Okay, in a way. So you're going to get this point. Okay, 0.3620 of acetic acid, 0.151 of water, and 0.487. Okay, as I've already told you, this is a raffinate layer, this is extract layer. So what you need to have to do first is that you have to join this point to this point to create a tie line. Okay, to create a tie line. Okay, equilibrium tie line, meaning that this point is in equilibrium with this point. Okay, then moving on to the next point. Again, we find the scale and we plot our point accordingly. And then we plot this point accordingly. And next, that point here, it will be here. And the other point of that one will be here. And you do it until you finish all the point. Okay. So I just did around 2, 4, 5 points. Okay. But once you have completed, make sure when you have located the points, make sure you join one of the point from the raffinate and one of the point in extract. So once you have joined the pair of the point, you will create a tie line. Okay, what happens with the middle section between the line whereby it is empty of line? So if in case your M or your point is somewhere in the middle of that empty space, what you have to do is that, say for instance, your M is somewhere around here. Okay. Okay. So for you to know the composition is that you have to draw a line. Okay. You have to draw a line. Okay. From that side to that line, draw another tie line, extrapolate or interpolate as you might have said, such that the line should be either parallel to the line adjacent to it. Okay, line itu mestilah selari dengan line yang bersebelahan dengan dia. Okay, so that line that you draw, okay, imaginary line that you draw should be parallel, selari with the adjacent line, dengan line yang bersebelahan dengannya. Okay, so once you have already drawn that imaginary line, then straight away you can read it from here and from this point where it intersects this line, this envelope. Okay, so with that you'll be able to find the composition of the extract, the aqueous layer, and also the extract layer. So that's it, how you draw the triangular diagram and the two-phase envelope using the data provided by the equilibrium data. I think that's all for now. I will continue later on to discuss about other example. Thank you, student.